Good evening, students. Today we are going to learn the topic atomic theory, the Dalton's atomic theory. So what were the various postulates of Dalton's atomic theory? To explain the laws of chemical combination. So this topic. After that, we will also learn about the atoms and molecules. What are the characteristics of atoms? How the atoms can be characterized, like their atomic mass, how they will combine, those things. Students, we have learned that these laws of chemical combination explains how the atoms combines to form the molecule. But the question was, how these atoms combine? Means why these atoms combine in fixed ratio? That was the other question. For explaining that one, different scientists proposed different theory. But the important one or the relevant one was Dalton's atomic theory. So right? So this Dalton, the full name of the scientist Dalton was your John Dalton. It was John Dalton who had proposed or given a theory theory means postulates means different statements. So John Dalton proposed a theory to explain the laws of chemical combination, because the laws of chemical combination were discovered before the discovery of atomic theory. So the purpose of John Dalton was to explain the laws of chemical combination. So laws of chemical combination. Laws of chemical combination means all the two laws of constant proportion as well as the laws of conservation of mass. So those things. So John Dalton have proposed the theory, means proposed following postulates. He was a Greek scientist. So following are the postulates of this Dalton's theory. So postulates mean important points are, so very first Dalton's told that if you are going to divide the matter, you are able to divide it to that extent at which you are able to reach to a smallest particle which will not further divisible. So that smallest particle which retain or which have the property of that particular matter, means that particular compound or element, is called atom. Okay, so the very first thing was, or the first postulate was, all the matter consists of atoms. Getting? So means go on dividing the matter, we are able to reach to a smallest form of that matter. That smallest form which is not further divisible is called atom. Okay, so write the detailed statement on dividing matter to possible extent, means up to what you can divide it to possible extent. Possible extent means, say I'm dividing this pen into two pieces. Then one piece I have taken again into two pieces. Then one of that piece, a smaller piece taken again into two pieces. Go on dividing. Means you are able to reach to a fine particle. That fine particle will not be further divisible. That fine or smallest particle was called as atom. So what we are Parmanu we were calling in beginning of this chapter, the same thing. On dividing the matter to possible extent, we reaches to the smallest particle of that matter called atom. Means the atom is the smallest particle which is constituting or making any matter. The simple thing was. Then this statement we can conclude that the smallest particle is your atom. Means atom is the building block, or atom is not further divisible. So write the definition of atom. The definition of atom was like this by the Dalton. So all matter is made of very tiny particle called atom. It simply means that. So all matter consists of or made up of very smallest particle. That smallest particle is very small in size, which is hardly visible with our naked eye. So it is called as tiny particle. So very tiny particle called, so this tiny particle was called as atom. Okay, student? Atoms, basically more than one atom was there in a matter. Means any matter consists of large number of atom. It simply means. The next postulate was these atoms cannot be divided further because it is the smallest or the building block or very tiny. Means further division of atom is not possible. So right, further division means breaking. It simply means breaking into pieces. So further division of atom is not possible. This was the other postulate. This postulate is also stated as atoms are indivisible. Okay, that is whether you state like division of atom is not possible or atom is indivisible. Be on time. So further division of atom is not possible. Student, we are discussing the Daltons Atomic Theory. So two postulates we have written. The third one is further division of atom is not possible. Means atom is indivisible. Indivisible. It is this one. So you just keep in mind this term, it is enough. Atom is indivisible. Okay, student. This atom is indivisible means atom will retain their identity even during the reaction. Means whatever the number of atom we are increasing, the mass of that matter will increase. As a result, indivisibility of atom explains the law of conservation of mass. because atom is the smallest particle of which a bigger matter consists of. And if it is, this atom is not further divisible, means that cannot be converted into the other form, then the mass of the atoms, means all the atoms of which the matter consists of, will remain the same as mass of the bigger matter. So this statement, so right, this postulate explains the which law? Law of conservation of mass. So ultimate purpose was to explain the laws of chemical combination, means law of conservation of mass and law of constant proportion. So that was the purpose. So for explaining the law of conservation of mass, Dalton proposed that matter consists of a smaller particle called atom, and atom is not divisible. So indivisibility of atom is the base for explaining the law of conservation of mass. So this was the third postulate or third point. Let us go for the next point, means the fourth point. Daltons also proposed different matter consists of different kind of atom. Say if I am considering this is the pane consists of iron and this is the pane consists of, say, plastic, then the atom of these iron will be different from the matter of this plastic. Therefore, the characteristic of this matter, means iron matter, is different from that of the plastic matter or wood matter. Are you getting? So that was the next proposition. So right, atom of a specific element or particular matter is of particular type. So write it. So atom of a given element, atom of a given element differ from atom of other element. A student, example, if we consider the iron, say iron, and if we consider the other element or matter as aluminium, then it is found that the atom of iron is different from the atoms of, so this is not identical to, three line means identical, not identical means cross it, means not identical to atom of aluminium. Students, iron is denoted by Fe. Someone is there? Lakshana, you are too late. Iron is denoted by the symbol Fe. So what are different element? What are their symbol? That we will learn tomorrow or in next class. Aluminium is denoted by Al. This you have to keep in mind. It is very useful. Not only in class 9th, even in 10th and everywhere. Student, we are discussing about the Dalton's atomic theory. Dalton have given different postulate or different statement for explaining the laws of chemical combination. So first he proposed that all the matter consists of atom. Then he proposed that atom of particular matter is indivisible. Then he also proposed that atom of one element is different from the other. Okay, but at the same time he has also proposed that, say, iron, if I am considering the iron piece, say this much is the iron piece, this iron piece itself consists of large amount of iron atoms. Now these iron atoms are different from the atoms of aluminium, but all the atoms of iron are identical among themselves. Means whatever the any atom you consider of the iron, that have the same characteristic. That was the other proposition. But if I consider the aluminium, say aluminium also consists of atom, but their atom will be of different characteristic. Means they may be of the different size, not only size, but their chemical characteristic are also different from that of the iron or atom of iron. Though all the atom of aluminium will be identical, means for the aluminium I am drawing, all the atom of aluminium are identical. So this is what? An atom of, so right, an atom of aluminium I have taken, and this represent an atom of iron I have taken. Okay, student. So here we can say, or here Dalton's proposed that atom of iron, means this is the iron atom, it is different or entirely different from the atom of aluminium in all respect. Okay, but he also proposed that if we consider iron only, then this iron piece itself consists of identical atoms. Okay, so all the atoms of a given element, a student, given element means we are considering, say, all atoms of iron only, means iron atom compared with the iron atom. So these two iron atom will be identical, but iron atom will be different from the aluminium atom. The two or more aluminium atom will also be identical, but aluminium atom will be different from the iron atom. Are you getting? So these two are the other important postulate you have to keep in mind. So all the atoms of given element means all atoms of iron or aluminium are identical, means they are exactly same in all respect. In all respect. All respect means they are identical in their properties like chemical behavior, their mass, electronic configuration, etc. So they are identical in all respect. Okay, so this was the other important postulate. So atom of one element or one matter is different from the atom of other element or other matter, but atom of particular element are identical. This was the fifth one. The next one, now a student, say aluminium and iron we have considered. Same way, there will be the other like carbon, oxygen, hydrogen, all the elements or all the matter consist of atoms. So I am now considering, just drawing, say carbon. So carbon also consists of particular kind of atoms. Say oxygen, whether it is in solid state or liquid state or gaseous state, that doesn't matter. Only a state indicate what is the spacing between these matters. Okay. So if we consider the oxygen atom, then we can observe that all the oxygen atom are also identical to each other, but these oxygen atoms are different from the carbon atom. For explaining the compound formation, Dalton proposed that certain number of one kind of element combined with certain number of other kind of element. So this combination is always in simple whole number. So right. The next postulate, 5 we have written, the sixth postulate. Sixth postulate explains the combination of atoms to form compound. So right, atoms combines in the ratio in the simple whole number ratio, whole number ratios to form compound. Form compound. Example, say if we consider say carbon, and let me consider the other oxygen. So to explain the formation of carbon and oxygen combines to form carbon dioxide, to explain the formation of carbon dioxide, Daltons proposed that this carbon atom and this oxygen atom, they will combine in simple ratios. Means one atom of carbon will combine with 2 atoms of oxygen, then it will form the formula. Say carbon is 1, so C1, oxygen is 2, O2, but 1 is not written, so it is simply written as CO2. So this was the other proposition or other postulate of Dalton, which explains the law of constant proportion. Similarly, he also told that if this ratio is changed, means one of the carbon combined with 2 oxygen to give carbon 1, oxygen 2. If one of the carbon is combining with one of the oxygen, then it will form the formula CO, and this CO will be different from the CO2. So this postulate explains the law of constant proportion. So we have to keep in mind, atoms combine in simple whole number ratio to form compound. It was this one. The relative number and kind of atoms are always constant. Means if the particular compound have to be formed, then the number and the particular type of atom that also need to be fixed. Say carbon and oxygen combine to form carbon dioxide or carbon monoxide, but in place of oxygen, if new element hydrogen is taken, then it will form different compound called CH4. Okay, so atoms combine in simple whole number ratio to form compound. So write the seventh one, the ratio or the relative number and type or kind. Okay, no, so whether the word kind written or type written. So the relative number and type of atoms that combines to form a given compound is always fixed. Combines to form a particular compound is fixed. Okay, student, so it was this one. Means carbon and oxygen, if I am considering, if you consider one atom of carbon, means number of atoms we are taking. So one atom of carbon and two atom of oxygen, it will form CO2. So it is one of the compound. It is called as carbon dioxide. Carbon dioxide. If this ratio is changed, say one of the carbon atom and one of the oxygen atom is taken, then the formula becomes CnO. It becomes a new compound called carbon monoxide. So it was this one, means changing the ratio. Here we are observing the ratio of carbon to oxygen is 1:2. In this case, the ratio is 1:1. Means changing the ratio, different compound is formed. These two are different compound. Even if we change one of the element, say if in place of oxygen, if we are taking now hydrogen, keeping the carbon as it is, so take one carbon, it combines with 4 hydrogen. Why 1? Then 4. This thing we will learn later. Okay, student? Why one carbon not combined with one hydrogen? There is a concept called bonding that we will learn later. Right now, you have to just keep in mind one carbon combined with 4 hydrogen. One carbon can combine with 2 oxygen or 1 oxygen. These are the only 2 possibilities. So if one carbon combined with 4 hydrogen, it is able to form the compound like carbon 1 but hydrogen 4, so CH4. It is called as methane. This have the name methane. Okay, if you change the ratio, say if you take the 2 carbon, then this can combine with the 6 hydrogen. The formula become C2H6. This is different compound and it is called as ethane. So we are getting these two are different. Means changing the ratios, the compound is changing. Changing one of the element, new compound is formed, means the compound is again changing. So this was the last proposition. The relative number and type of atoms that combines to form particular compound is always fixed. Means if the number or the type of atom is changed, then new compound is formed. That is, here you may add, if the number of atoms or ratio of atoms or type of atom or type of atom is changed, then new compound is formed. So student, here we are observing that Daltons postulated that the number of atoms that combine is in simple whole number ratio, and changing these ratios or changing the number of atoms, different compound are formed, or changing one of the element of the compound, new compound is formed. So this was same as the law of constant proportion. The law of constant proportion also tells that atoms combines in fixed ratio to form compound. The same thing was stated by Dalton but in different form. He stated that the number and type of atom combines to form particular compound is fixed. So mean the same thing. So right here, this postulate, this is important, postulate explains the which law? The law of constant or definite proportion. Good. So the ultimate objective of Dalton was to explain the two laws. One was the law of constant proportion. For explaining this, he assumed this postulate: the relative number and type of atom is always fixed in any compound. And another postulate, he assumed that atoms are indivisible. So considering atoms as indivisible, he explained the law of conservation of mass. So this way the two law of chemical combinations were explained. But a student, with latest discovery, it is found that these atoms are further divisible. So at that time, or at the time of Dalton, means in 18th century, it was okay. But with the development of technology, it was proven that atoms are further divisible. This we will learn in our next chapter, where we found that atoms can be divided into electron, proton, and neutron. Okay, so that was the major drawback of Dalton's theory. So right, major drawback or limitation of Dalton's theory. Dalton's theory or Dalton's postulates. So what was the drawback? The drawback, he assumed that atoms are indivisible, but later on it was proved that atom can be divided further. So right, Dalton assumed or proposed that atoms are indivisible. So this was his assumption, which is proven wrong, which is now proven wrong. Why? As atoms can be divided into subatomic or fundamental particle, into write as subatomic, write in the bracket, fundamental particles, like what they are. The very first one is electron, second one is proton,
Proton.
yes, the third one is your neutron.
Neutron.
Okay, student. So this was discovered later. So the assumption that atom is indivisible is wrong. So this is the major drawback. So what Daltons assumed was that atom is like this. So according to Dalton, so Dalton tells that atom means it is just a sphere or it is just a tiny particle. It cannot be divided further. But now it is found that this was Dalton. But now it is found that if you consider this as the atom, it consists of two parts. One is the central part, which contain proton and neutron. So proton is denoted by P and neutron by N. This we will learn in our next chapter. So this atom consists of a core or central part which contain proton and neutron. How much or what is the number of proton and neutron, that we will learn later. So number of proton and neutron varies with different kind of element. And he also found that, and now it is being discovered that in the center region proton and neutron are there and electron are in this outer region. So electron, it is found that these electrons are revolving around this. So this is now new model. So this is called as the nucleus. This nucleus contains two kind of particle. One is proton and other one is neutron. So these proton plus neutron are collectively forming the nucleus. Okay, and the electron is revolving around it. So this is the electron which is revolving around it. So this is our electron. It is outside the nucleus, so it is also called as the extranuclear particle. This thing we will learn in more detail in our next chapter. So student, this was the Dalton's model or Dalton's proposition, but the fact is this one. Now atomic model is this one. Means it is being proven that this atom, if this is the atom, it can be broken into different kind of particle, though only 3 are in your syllabus, so I am writing the 3, but there are many more other subatomic particles like protino, neutrino, antineutrino, many more are there. So these atoms can further be divided into proton, neutron, or electron, proton and neutron. So right, electron or electrons, protons and neutrons. So it is this one. Means now it is found that these atoms can be divided. Means it is not a single pair, but rather it can further be divided into three kind: electron, proton, and neutron, denoted by E. We will learn in next chapter. This is negative charge, so E minus is denoted. This is containing the other kind of particle, proton, which is positive charge, and neutron denoted by N but do not carry any charge. So this was the major limitation of Dalton's atomic theory. Okay. So what are the drawback of Dalton's atomic theory? The drawback was atom is divisible. So that is, so limitation is what? Or what was the wrong with Dalton's atomic theory? Atom is divisible. Now atom is divisible. But Dalton stated it is not divisible. Okay. So this way Dalton was proven wrong, but not at that time. After many more discovery. Who was Dalton? Dalton was a teacher. Okay. And he was a researcher. So this proposition, I mean the basic assumption of Dalton that atom is not divisible was proven wrong. So this is the major drawback. That's why nowadays Dalton atomic theory do not carry any more or any much significance, but during a study we are just learning it. How this development have taken place, for that purpose we are learning. But nowadays Dalton's atomic theory is not relevant. So right, therefore nowadays Dalton's atomic theory is not relevant. So question may be asked, why Dalton's atomic theory is not relevant nowadays? Because it is discovered that atom is divisible, but Dalton has proposed that atom is not divisible. So therefore nowadays Dalton's atomic theory is not relevant. Relevant means useful. So it is now not useful, but still we are learning this as a history. Okay, student. So this was all about the Dalton's atomic theory. It is very important and questions are asked. So all these 7 postulates are equally important. Drawbacks are equally important. So Daltons have assumed certain thing to explain the law of conservation of mass. Means the assumption was atoms are indivisible. He assumed that atoms combine in fixed ratio or simple whole number ratios, and particular kind of atoms only combine to explain the law of constant proportion. So 7 postulates were very important, and this was the drawback. Now let us go for the question of our textbook. What are different questions that is framed? So student, I hope you people can do it, but let me explain. So question on the page number 32 that I am going to do. Student, all this question I will explain. The other question is like this one. It is in continuation to that. So let us copy it at the same place. So we have to answer these questions. Yes, students, can you answer it? I hope so. You shall answer and you shall write it as homework, but let me give you the hint. So let us start with the last one. Which postulate of Dalton's atomic theory can explain the law of definite proportion? Yes, student, can you tell me the answer to this question number 4? Which postulate? That not the postulate number 1, 2, 4, 5, 6 that you have to write. You have to write the statement. Okay. So which postulate of Dalton's atomic theory explain the law of definite proportion? It was the assumption, or it was the postulate that atoms and
ratio of atoms or type of.
good. So the number of atom and type of atom is fixed, or atoms combines in simple whole number ratio. Simple whole number ratio. This was the assumption. Also, the number of atom or number of atoms and type of atoms are fixed in particular compound. So this was the assumption, this was the postulate. So these two postulate, or collectively you may write this as the only one postulate, means atoms combine in simple whole number ratio. If only this much is written, that is also okay. Or atoms and their type is always fixed for particular compound. So this explains the law of definite proportion. Next question is, which postulate of Dalton's explain the conservation of mass? Yes, student. Which postulate explains? It was atom is indivisible. This postulate explains the law of conservation of mass. Good. Now coming to the question number 2. Hydrogen and oxygen combine in the ratio. So this is the question based on our law of constant proportion, where it states that hydrogen and oxygen combine in the ratio of 1:8. See how? Hydrogen you have to take at one place and oxygen you have to take at the other place. So hydrogen is H2, oxygen is O2 to form the water, H2O. Here the ratio we have to take in the term of mass. Here 1:8 is given, so do not think ratio is 2:1. So 2:1 is in the term of their number of atoms. So it is the atoms ratio. But in the term of mass, if we take, then what is the ratio? So hydrogen, it is found that this hydrogen is always 2 gram, which combines with oxygen of 16 gram. It is basically the 16 is the atomic mass, but O2 is there. So 16 into 2, it becomes 32. So right, oxygen, this we will learn later, student, but how to keep in mind? See, hydrogen have the atomic mass 1, but while it is in H2 form, it is 1 into, because 2 numbers, so 1 into 2, so it becomes 2 gram. Therefore, I have written this as 2 gram. Similarly, oxygen have the mass number 16, but O2 is there, so 2, so 16 into 2, it becomes 32 gram. This we will see in tomorrow or next class. So it is combining with 32 gram. So how much gram is this? Again, H2 means 2 gram plus 16 gram means this 2 gram, but this O is only there. So it is your 16 plus 2 is your 18 gram. You will find this as 18 gram. But to balance this, observe this oxygen is not balanced. So first you need to balance it. So last day we have done here, we have to put the 2 at the same time. We also need to put the 2 here. So while putting this 2 here, I will have to put the 2 at this place. While putting this 2 here, I will have to put the 2 before the 80. So total it becomes 4 gram of hydrogen combines with oxygen. Number is not changed. So 32 gram of oxygen to give 36 gram of water. Okay, student. Now here you have to take the ratio. What mass of oxygen would be required to react completely with 3 gram of hydrogen gas? Now the question is like this. So a student, let me take this part or create more space. So question number 3 I am explaining, students. So let us consider this question number 3 in more detail. Here we are observing that the 4 gram of hydrogen is combining with 32 gram of oxygen to give 36 gram of water. Now the question is that in this question it is given that what would required for 3 gram of hydrogen. So if the hydrogen is 3 gram, then how much gram of oxygen is required? So how much this is required when this is made 3 gram? So simple arithmetic we have to do. And how much gram of water will be formed? A student, just you observe this carefully. 4 gram need 32 gram. Okay. So 4 gram, you may write like this. 4 gram of hydrogen needs how much gram? 32 gram of oxygen. Now when this 4 gram is replaced by 3 gram, then the oxygen 32 gram also have to be reduced. So how much is that? You are observing that when this is 4 gram, it is 32 gram. Are we getting like this? Means if it is reduced to 3 gram, then how much will be this? This is the question. A student, you can observe that 4 gram gives the 32 gram. Means 1 gram reacts with how much gram? 8 gram. Means from this 4 gram, if 1 gram is reduced, then from the 32 gram we need to reduce the 8 gram. Are we getting like that? So that way we can also understand, or the other way is just 1 gram need 8 gram. So multiply this by 3, means 3 gram will need how much? So it will need 3 into 8 gram.
3 into 8.
Very good. So 3 gram of the hydrogen will need how much oxygen? 8 3 is 24 gram. So 24 gram of oxygen. So this way, simple mathematics you have to do. So whatever I have explained in this side, that I am going to write in language. So student, here 4 gram of hydrogen need 32 gram of oxygen. Therefore, 1 gram of hydrogen needs how much gram? 32 by 4, because it will come in denominator, is equals to 32 by 4 gives us the 8 gram. Whatever 8 gram I have written here, the same 8 gram. Okay. So 8 gram of oxygen. That is 1 gram of hydrogen needs 8
8
gram
gram.
of oxygen. This I have written in the language. Therefore, if this is taken 3 gram, means increased by 3 times. So while the hydrogen is increased by 3 times, in the same ratio, we have to be increased this oxygen. So 3 into 8 gram of oxygen, because this is like equation. So increasing one, you need to increase the other one also. So it become, so therefore 3 gram of hydrogen needs
24 gram of oxygen.
very good gram of
Sir,
oxygen. Yeah, tell me.
sir, can we do it by cross multiplication?
Yeah, that is the same thing. Or you may just understand the other way just by taking the difference. Say 4 gram reacting with 32 gram. So 1 gram is reacting with 8 gram. Now taking the difference of this 1 gram from this 4 gram, we are getting this as the 3 gram, means 4 gram minus 1 gram. So this will be the 32 gram minus 8 gram. So 3 gram will react with 24 gram. So whatever the mathematics you are using, it doesn't depends on that. But the concept is that which one needs how much. The best habit is just by applying the multiplication. Take 1 gram of hydrogen reacting with how much gram of oxygen. So this was the answer. A student, here we can also say how much gram of water will produce. A student, here you are getting that 4 gram is producing 36 gram of water, 4 gram of hydrogen. So let me also write that. So we may write like this. Also, this is the additional thing which is not in question. So 4 gram of hydrogen gives 36 gram of water. Means 4 gram of hydrogen produces 36 gram of water. So 1 gram of hydrogen will give or produce how much? 36 by 4. So it becomes 9 gram. 9 gram of water. So the 3 gram of hydrogen will give how much gram of water? 3 into 9.
27.
Good.
27.
So it becomes 27 gram of water. Though it is not asked, but we can calculate. It means this 3 gram needs how much? 24 gram of oxygen. And that will produce a total 3 plus 24. That can also be written as simply 27 gram of water. Okay, student? So this way, like mathematics or simple mathematics, we have to solve this. So this way I had explained how. The same thing is also in our question number 1, but you please do it. Okay, student? So one question I had explained. Tomorrow, I will ask this question from question number 1 from you people. Whether you have solved it or not, then I will also explain
Okay, sir.
tomorrow. Okay, student? So write down
Okay,
your
sir.
homework. Let us start the class. So our homework is like this. Our chemistry or science chapter 3, question number, so blue question on page number. So the question that I have already written here, 1 to 4. It is on our page number. Which one page number it was? 36.
32.
Good. So it was on the 32 and 33. So page number 32. Okay, student. So please do this. Tomorrow we will meet. A student, I am teaching a bit slow so that you can understand. This is very important part of chemistry. This third chapter and fourth chapter, because third and fourth chapter are the base for your class 10th. In class 10th, you have to learn about the reaction. You have to do many kind of calculation. You have to learn about a lot of reaction. So without knowing these atoms and molecule, how atoms combines to form molecule, what is the molecular formula, what is molecular mass, you cannot write the reaction. So it is very important. So last day we have learned about law of combination, means laws of combination, and today we have learned about the Dalton's atomic theory and how these laws of combination are applied and how this Dalton's atomic theory explains the law of combination or laws of chemical combination. Those things we have learned. So we shall stop the class here. A student, any doubt in this chapter or what you will learn till now, then please ask. But you people, please watch the videos. You people do the homework. If you are not doing, then it becomes difficult for you to understand. And once the chapter is over and you have not understood, then it becomes very difficult for you people to